This is AS Statistics, and we're looking at histograms. So the previous video went through talking about histograms, and this is just a short video then on reading a histogram. The best way to do this is to draw a table and work backwards from the frequency density. Be careful if it is frequency per 2 or per 3 or something like that. The one we have below is just regular frequency density. So let's take a look at this example and work our way through it then. So it says this histogram shows the time taken to the nearest minute of a doctor's appointments. How many appointments were there altogether? Estimate the percentage of appointments that took longer than 6 minutes. The secret to this, as it just says there, is to get your table done and find the frequency then from there. I can see that that's 5, so that must be 0, 1, 2, 3, 4 and 5. So this here one, the group width says we're going from 1.5 up to 3.5, so that group then must be then between 2 and 3. So let's see what we're going to have to fill in here first of all. So if we do our boundaries, I think, and we can kind of then work backwards from there, I think that probably makes the most sense. So as you can see, that boundary then is 1.5 up to 3.5. Just reading it straight from the histogram. This one is 1 wide, so it's going from 3.5 to 4.5. Next one, 4.5 to 5.5. Next one is 5.5 up to 7.5. I think you can just see it there. So there's your 5.5 and then 7.5 there. Then 7.5 to 10.5. You can't quite see that. You have to take my word for it. So it's this one here, and then our final one is 10.5 up to 15.5. Yeah, we'll do class width in a wee minute, but we're just going to read off then our frequency densities in for each of these. So here, that's halfway between 10 and 20, so it's going to be 15. That's 96, I think. That's a 48, 42, and then 9 and 3. So if we fill in our frequency densities, the idea of doing this is so we can effectively work out our frequency. So 15, 96, 48, 42, 9 and 3. Our class width then, so 3.5 take away 1.5 is 2. That's 1. That's 1. That's 2. That's 3. And that's 5. And how do we work out then our frequency? So if we have our frequency and we have our width, how do we work out our frequency density? We did this divided by this to get this. So we need to multiply these up then. So the frequency of this one's going to be 30, 96, 48, 84, 27 and 15. And then just for completeness, hopefully you can see this has been done to the nearest minute, so between 1.5 and 3.5. So that group is simply 2 to 3. This one is 4 to the nearest minute, 5, then 6 to 7, 8 to 10 and 11 to 15. So what have I done there? I've converted this histogram into the table. Now I have, I guess, not quite the raw data, but I have the information I need then to answer the questions. So how many appointments were there all together? That's a straightforward one. We just need to sum that up, and if you add all those up, you're going to get 300. So our answer to part A then is 300. Next one's a wee bit tougher. Estimate the percentage of appointments that took longer than 6 minutes. So you can do this a couple of different ways, but if we can see, this group goes from 5.5 up to 7.5, and we want ones that take longer than 6 minutes. So if it's 5.5, it's maybe easier to show then from this if you just sort of split it up in the thing. It's this group here, and I'm going to split this group up into, that's 5.5, that's 6, that's 6.5, and that's 7, and that's 7.5. So that group there is going to be there, and we want the ones that take longer than 6 minutes. So there's your cutoff there. So I want 3/4 of this group here. That's quite hard to see, plus this group, plus this group. So I need 3/4 of the size of this group. That would be how many were estimated more than 6 minutes. So let's write that in. So 3/4 of 84 is going to give you 63, and then the other ones 63 out of this group here, and then 27 and 15. So it's going to be 63 plus 27 plus 15. That gives 105, and then as a percentage in of the whole amount, so it's 105 over 300 multiplied by 100%. So our estimate then is going to be 35%. While we're here, we'll just chat about the other bits and pieces. Other types of charts, you should be able to interpret other statistical diagrams such as bar charts. A bar chart compares frequencies. Pie charts, I mean, this is year 8 stuff really. Pie chart compares proportions but obscures the individual frequencies. Vertical line charts and dot plots. If you have two data sets of different sizes, you want to compare them, then it is easier to draw conclusions from a pie chart. Hope that makes sense. You know, if say you wanted to compare maybe two different schools, and one school has 3,000 pupils and the other one has 300 pupils, your bar charts are going to look like this. This is just, making this up on my head. Hopefully your bar chart, say this is the big school, and then the wee school. And it's very, very hard to compare. So you're trying to compare, the amount in each year group or something like that, or people who pick different sports or whatever it is, and they kind of look like that. Whereas if you do a pie chart for this information, it doesn't matter in the frequencies. You'll get a good idea then and be able to compare the different sections that you want. So that's the point then that they're making then about the pie chart. So it says if you have two data sets of different sizes and you want to compare them, then it is easier to draw conclusions from a pie chart. That's the only point that's making that about there. Okay.